Hi, everyone. I'm Chistine Huang. I'm here in Hong Kong. Thank you very much for having me here. This year, together with our amazing team, especially Eva, Alexei, Morton, and Alex, I have developed and recorded the Introduction to Longevity Medicine for Physicians course in Chinese. I'm glad to join the longevity medicine workshop in the ARDD here and give a presentation on the topic, biomarkers and geoprotective interventions from traditional Chinese medicine to modern discoveries. Although I am a Chinese, I'm not a traditional Chinese medicine practitioner. I'm trained in Western medicine. However, traditional Chinese medicine and Western longevity medicine both have the same shared goals to live longer, healthier, and more energetic lives. Therefore, I would like to start with an overview of whole Western and Eastern longevity-related concepts. First of all, let's look at our left-hand side. Well-being or yin yang shen refers to maintaining a state of good health from daily life and habit, which is deeply ingrained in Asian culture. The core concept is the balance between yin and yang. Another more extreme concept is immortality. Let's look at I put that into our right-hand side, which refers to the eternal life. The first emperor of China, Qin Huang, wanted to be immortal. The oldest book of traditional Chinese medicine is called Huangdi Neijing and is derived from conversations between the emperor and his chief physician. A wide range of anti-aging herbs were used and the formulas created in attempts to create the elixir of life. In between, longevity, as understood in the Western, relates to the duration of life. It doesn't only consider the length of life. It also focuses on the quality of that long life and healthy aging. It's based on aging biomarker discoveries, which we will also discuss in this workshop, as well as related geoprotective interventions. So when we compared traditional Chinese medicine to modern medicine, I have to say that two beautiful methods and logics to help people and treat patients. Traditional Chinese medicine that focused on treating patterns, while modern medicine that is more focused on treating symptoms. Traditional Chinese medicine diagnoses through the symptoms and appearance of the patient, while modern medicine diagnoses through lab tests, especially biomarkers, and focuses on eliminating symptoms. Traditional Chinese medicine regards the bowel system as a whole, with all organs linked to each other. Well, modern medicine that the trend is the precision medicine and treatment of specific organs. In the world of traditional medicine, herbal remedies for well-being and longevity based on practitioners' experience. Where modern medicine, we are using geoprotectors and senolytics. That's based on aging biomarkers and aging pathways. Therefore, let's look into the aging concepts of modern medicine, which is based on the accumulation of errors at different levels of organization of a living system. For example, the molecular, cellular, tissue, organ-specific, and systematic. The more generally accepted point of view is that The exponential growth of the accumulation of error is explained by the gradual failure of the systems for repairing errors and maintaining homeostasis. Metabolic errors accumulate at different rates in different individuals. The rate partially depends on the genes. For example, the mutations in progeria syndromes. And to a much greater extent, metabolic errors are associated with the influence of factors of the internal and external environment. For example, toxic substances, ionizing radiation, low frequency electromagnetic fields, etc. That is activation of aging-associated signaling pathway by particular metabolites. It is worth noting that epigenetics is involved in this case, since all these factors affect the active of gene. In a healthy young body, for example, the cause of metabolic errors are repaired, removed, and replaced very soon. However, with age, breakdowns gradually accumulated in these recovery systems themselves, which leads to impaired maintenance of homeostasis and adaptive capabilities, and increase in the risk of age-related death and disease. So there are 5 levels of aging, which including in systems level, organ level, tissue level, cell level, and the molecular level. So can we track the hallmarks of aging on the individual level? There is no universal biomarkers of aging besides chronological age yet. Understanding the causes of aging has already made it possible to collect sets of aging biomarkers that reflect the rate of age-dependent changes. So, what aging biomarker is? That is a set of measurable parameters that can change reproducibly, quantifiably, and quantitatively with human age. And many of those markers will help us translate the experimental therapies into clinics by measuring the effects of those interventions on those aging biomarkers. We'd like to call it aging clocks. The aging clocks, based on those markers, we can now predict the accelerated or delayed aging for individual or for group, monitor the effectiveness of these various therapies aimed at prevention or even a reversal of aging. You can look at diets, lifestyles, increased physical activity, and geoprotective interventions. So now we have the tools for the first time to quantitatively and consistently measure the rate of aging in response to various interventions. And there are some criteria that we have defined for aging biomarkers. The aging biomarkers need to be correlative, or they need to be correlated well with the chronological age in the healthy state. They need to predict mortality better than the chronological age. They need to predict the early stages of specific age-related diseases or many age-related diseases. They need to minimally invasive and do not require serious interventions or painful procedures. So do not want to sample somebody's brain from time to time just to figure out how they age. Besides, there are also some additional criteria. So ideally, those biomarkers need to be sensitive to early signs or of aging as opposite to mortality or fertility. So we would be able to measure some of the midnight processes. They need to be predictive for foreseeable period. So you might be able to predict what's going to happen with the patients in the near future. It has to have low analytic variabilities. They need to be robust and reproducible, especially on the individual level. So if the patient is 80 one day and 35 the other day, and then they're 17 on the third day, that's something you don't want to see in the aging clock. Even so, some of those clocks might be useful for specified applications. And some of the application-specified clocks might jump like that. Sometimes as a physician, you want them to jump and that in response to, and for example, you're giving your patient an intervention, geoprotective intervention. So the biological age could be defined and classified into three categories and measure it using three approaches. One is clinical and functional testing. That, for example, you can look at the inflammation, insulin resistance, lipids, etc. Also, you can look at the face appearance and the body strength. That is basically linked to the biological age to a specific phenotype or a biological process. Then there are aging mechanisms based on base analysis. Thinking of those as aging clocks with specific hallmarks of aging, that would be a clock that would measure cellular synthesis, telomere length, actual, and many other hallmarks of aging. You can basically design clocks that are measuring specific function, performance, and work within the specific aging mechanisms. There are omics-based clocks. If you just want to build predictors of chronological age in a healthy state using any data type to derive those new insights and maybe even form some new hypotheses, you would use omics approach. That is something that we can use a lot. So we would use metabolomics, transcriptomics, metagenomics, proteomics, and DNA methylation clocks. DNA methylation and other kind of multi-omics approaches can combine multiple data types together and predict the person's age in an ultimate healthy state, either for a specific population or for or population group, or even on the individual level. You can train one of those clocks on a population and then retrain another specific individual using the data coming from longitudinal studies on one person. There are multiple combinations of biomarkers. So currently, it's very difficult to select just one biomarker of aging that would satisfy all of the criteria that we have just described. It's extremely important to have many age clocks. About this specific individual or population group, those biomarkers need to be combined in a clinical study because many of those biomarkers, they have advantages and limitations. That's why you're going to have hundreds of them. As we have discussed biomarkers of aging, let's have a looking at geoprotective interventions. Chinese explored longevity methods for thousands of years. Although there are many theories of anti-aging in traditional Chinese medicine, The most important is the association of aging and decreased immune function. Therefore, the anti-aging formulas are majorly function-based. There are many formulas for enhancing longevity in traditional medicine. The main ingredients of these formulas are herbs such as huangqi, which is proved antioxidant, anti-apoptotic, anti-inflammation, and the Renshen or ginseng root helped on non-specific immune system, regulates imbalance of endothelin system, promoting blood circulation, and anti-toxicity functions. While the discovery of geoprotective interventions of modern medicine are pathway and biomarker target-based. Some of the most popular ones that you might want to take a look at is something that we are likely to be able to track with a clock, that is NAD booster. So recovery of NAD plus levels, TOR inhibitors, inhibition of TOR using with myosin or other TOR inhibitors like avarosum, the largest RAD001, but there are many of them, and elimination of senescent cells use senolytics. So all of those could have effects of aging clocks. And now a lot of people are exploring those in the clinic. Except for drugs, lifestyle intervention like nutrition, physical training, and sleep are accepted both in traditional Chinese medicine and Western medicine. Even traditional Chinese medicine and modern medicine share different knowledge systems. The traditional Chinese medicine and longevity medicine pathways do have some intersections. For example, Huanglian, we can also call it Arzoma corticosteroids. Data is summarized that the evidence support is extraction, but brewing is a promising anti-aging natural product. The mechanisms of its effect involves antioxidation, activation of AMPK signaling, and its downstream target, including mTOR. At the end, it's actually a lot of easy geoprotective interventions can be applied to our daily life. I suggest go hiking with friends, the fresh air, physical activity, and the social contact, and plenty of laughter with good friends will help promote both physical and psychological longevity. Thank you. Thank you all of you. Thank you a lot for listening. A lot of information I have cited, I have talked in this presentation that is cited from Longevity Medicine course of physicians. Welcome to join our course to get more detailed knowledge in longevity medicine. Thanks again.